Sorry about the late start. I was in the lab and it started raining here, so I couldn't come in time. But anyway, since I said 6:10, let's wait till 6:10. In case people have left and are going to join in 6:10. Yeah, good evening, everyone. So, in the meantime, I just wanted to say, just as blanket statement, today only I noticed this actually, that some mails that I think you people have written some mails to me have been sent to the spam filter in my inbox. I'm really sorry about this. I had no idea actually. Today only when I was clearing my inbox, I saw this. So, if any of you are facing this issue, like that I have not replied to your mails or something, please one sec. Yeah, please just let me know, or like maybe you can tell me in the chat or something, or bring it up during the meeting. I didn't know about this. Now I'll just check my spam filter also recently. Can I get a link of the forum? I am not able to access the link. Are you talking about the Google discussion forum or something like that? So one, if you have Python doubts, you can clarify it in this class. But yeah, if you have doubts related to the assignments and other things, let me just share my screen. I'll show you how to do that. So one sec, let's move this. Yeah, if you just go to the course, so this is your course page, right? Sorry, one sec. So this is your course page. Just logging in. And then here you have this Q&A, if you can see. So here all your week materials are there. Actually, from here you can get the recordings of the problem solving sessions, but also you can use the link to my website. And other than that, here you have this Q&A. So if you click Q&A, it will say you're going to a discussion forum. So if you go there, I think you will find this discussion forum. As you can see, many of your friends have already asked questions and all that. So if you have any assignment or exam kind of questions, you can ask here. But if you have Python doubts, you can also clear it in this session because I can help you. I am just not in charge of correcting assignments or setting assignments, so I might not be able to help you with those kinds of questions, logistics questions. Okay. So yeah, as I was saying before that, yeah, if any of you have sent mails and I have not replied, just know that it's because of this issue. I don't know why. I don't know how to disable it. So in case you send me a mail and you don't see a reply, just send me another mail or just bring it up in the class so I can go and check my spam folder. But now I will also regularly check my spam folder in case I miss anyone's mails. Okay, fine. Okay, it's like 6, 8. Maybe we can slowly start and then people can join in the class. Yeah, okay, fine. So let me just share my screen. Okay, okay, screen is already shared. Let me just open the PowerPoint. One sec. Week 4. Yeah, okay. So, yeah, so again, if you're joining for the first time, welcome to week 4 of this Python problem solving session, Joy of Computing Using Python NPTEL sessions, problem solving session. Essentially, these are like supplemental sessions to your main course. So, in your main course, you will actually learn the theory and other things, which I will not be teaching you again here. Instead, what we'll do is, as the name suggests, we'll solve some problems together. So, these will be like your MCQs that you do in your quiz assignments, but we'll also do some programming assignments together. And this is meant to be hands-on interactive session, so feel free to ask me questions at any point. And also, as I said, you can mail me throughout the week. I just discovered that some of the mails you were sending me were getting categorized as spam for some reason. But please, I encourage you guys that throughout the week, if you have any questions relevant to Python and the course, you can mail me. Specifically, if you ask me questions about the assignment, I might not reply because it's up to you to try and figure those out yourself. But if you have any conceptual questions or doubts, I can answer. I also can't really help you with exam details or assignment submission details kind of thing because I am not in charge of them. So I'm just trying to clarify these things. Apart from that, all the sessions, slides, programs, videos have been being shared, and I hope you guys have been able to access them. So in case any of you need it, all the links are available on my website. So I maintain a page for this course on my website, but also the NPTEL course will do. Can you take more programs this time so that we get time to think first, then see the solution? Fantastic. Yeah, let's do that. In fact, I'll give you some more time to think about the question. And uh, okay. So let's try to go through the MCQs quickly this week. I won't spend so much time. And yeah, again, as I was saying, this is the links for the website. So here all the links to the videos and the programs, everything is there. So sometimes I try to give you time to solve the program on your own. So that's why that even if I can't discuss all the programs, I try to at least give you some time. So I'll give you some time today to solve the programs. Because as you know, as I've told you, programming is such a thing that you have to try it yourself. Otherwise, you will not be able to yeah, you will not be able to do it, because if you by seeing someone program, you won't be doing. So yeah, so I have been doing programming assignment of week 3, but there's always one error of presentation error. I know what the error is, but it is difficult to remove this error. So I am not very sure about what format they're expecting, but I can see that someone has given some solution to it. So maybe you can try whatever this person has suggested. If that also doesn't work, you can try it in the Google forum or something. If it's a presentation error, I think they don't dock points, right? They don't cut points for that, as far as I'm aware. But still, if you want to know about it, then you can. Yeah, maybe you can try this suggestion. If anyone else in the class has faced a similar error and fixed it, maybe you can help your friend out in the chat. Okay, fine. So yeah, this week let's try to yeah, I think last week we spent a lot of time on the MCQs. This time I don't know how many MCQs we have, but let's try to go through them a little faster and spend a little more time on programs, which is only what's important. Both of those are important. Anyway. So yeah, again my website I've shared in the chat, so all the links are there. Blah blah blah. I'll tell this again at the end of the class. Okay? Fine. So in this week's lectures, this is week 4. So you have seen about matrix operations, magic squares, and about all this double and guess the movie game, right? So matrices are very important because that's usually how you handle a lot of data at the same time, and you learned about a lot of ways in which to do that. So one thing I'll just mention before we go to the class is that I have just muted everyone and disabled mic access because of the large number of people in the meeting, and it was causing disturbance when one person unmuted by mistake, for example. But if anyone wants mic access or wants to ask a question, please write it in the chat and I will grant you mic access for that moment. I'm just disabling it as a precaution. Okay, but feel free to ask questions on the chat, or even if you want to speak up and ask, please feel free to just write that in the chat as well. I will grant mic access. So I'm just muting everyone as precaution. Okay, fine. So I always start with this slide. By now you would have realized, but again, I want to drill into you how important it is to not only write code, but good code. So please make sure you follow all these things when you write your codes. Give good names and give proper spacing to things so that your code is readable and understandable, and put enough comments that anyone who picks up the code is able to understand what exactly it is about. Okay, so the reason why I brought in lists is because when we talk about matrices, we often represent them as lists in Python. So two-dimensional list can be thought of a way of representing a matrix. There are also specialized Python libraries for dealing with matrices and data in general, like NumPy and Pandas, for example. Particularly, NumPy is made for doing numerical calculations on arrays and matrices kinds of objects. So remember, one of the big what can I say? Plus points of Python is that it is an open source language, and also and as a result anyone can write a library or modify a code in Python and contribute to Python, basically contribute to its development. And so you'll see a lot of user defined libraries and other things which can actually help to get the which can actually help you. You don't have to code everything from scratch, is what I'm trying to say. So these are your data types, operators, and these are the things that we'll be using. So I'm just flashing it again. So data types can be of different types, integers, floats, strings. We've used a few of them now. And then you have containers for the data types, which can be lists, which we have been using for the last 2 weeks. But then we'll also be learning about other kinds of data types like tuples and dictionaries shortly. So these are the operators that you use in order to, do any operation that you require on a particular data that you have in Python. So magic square basically is a program, or sorry, magic square is a construct in mathematics where you have a square matrix, and it's an arrangement of n squared numbers. So n numbers, n by n matrix, and it has a special property that the rows and the columns and the diagonals all sum to the same number. So a magic square of order n will have the integers from 1 to n squared. So magic square of order 3 will have all the numbers from 1 to 9, for example. So there is a way to construct a magic square which is very nicely given in this website. I'm not going through the details. I think it's there in your lectures, but again, if you have any doubts, you should go to it. And if any magic constant of a normal magic square depends only on n, it has a following value. Okay, so these are all mathematical things, but you saw how to program that. So without any more details, let's go to the questions and let's try to do the MCQ so you get more time with the programs. And let's see. Okay, which of the following options, so I just showed this in the previous slide, but which of the following options provides a general formula for the magic constant of a magic square of size n? And these are multiple select questions, or multiple answers are correct here. Please put your answers in the chat. Okay, A and C. One person says A and D, A and C. Okay, okay, okay. Okay, I can see most people are saying A, most people are saying C. Some people are also saying B and D. Maybe we can go to the answer. I can see a lot of you have answered. So the answer is actually A and D. Just look at it carefully. N into n squared is n power 4. Sorry, then there's a 2n here. So that's why it works out, right? Whereas in C, n into n squared is n cube. N into n should just be n. It should not be 2n. So that's why it's wrong. But this is the correct option. These two are mathematically equivalent. And you can look at this solution later if you want. So again, this is related to the mathematical property of magic square. Next question. What would the magic constant be for a magic square of size 7, given that all elements in the square are distinct numbers from 1 to 49? So here just use the property that we just derived. Okay, I can see some answers. Okay, I can see people are saying C. One person said D, but most of you are saying C. Okay, that person. I'll just give one more minute in case someone is still solving. Okay, I think most many of you have answered. Anyone else? If you're working out, I'll give you a minute. But okay. Okay, fine. Let's go to the answer. The answer is C. So again, if you put it in this formula, you'll get 7 into 49 plus 1 is 50. So that's 7 into 50, which is 350. 350 divided by 2 is 175. And that's why the answer is 175. Okay, good. Next question. Does transposing any magic square change the sum across rows, columns, or diagonal? Okay, no, no, no. Okay, I can see immediate answers from people. B, Okay, okay, fine. So I see that this time there's clear consensus. Yes, the answer is no, because as we know that there is magic square has the same sum among rows and columns. So no matter if you compute it in any direction, you're supposed to get the same answer. Okay, great. Select the correct statements regarding the magic square. So again, these are the questions that are asked to solve because this week you dealt with magic square. So correct statements here. Okay, I see B, C, and D. D we just calculated, right? 7 cross 7 magic square. Okay, okay. I can see many people are saying C. Some of you are saying A. This is my second class. How can I find recorded classes? So I said in the beginning, my website is there. I sent it in the chat. Just scroll up. Otherwise, at the end of the class, also I'll be sending my website. Other than that, the NPTEL team should be sending you the details of the thing as well. Okay, maybe we can move to the answer of this question. The answer is actually A and C. Okay, so because magic square of order one is trivial, because of course any order one magic square means it just has one element. Order two is actually not possible, and this you can show as well. Uh, the sum of two magic squares is not a magic square. So let me try to understand why. Because I guess the diagonal will not be conserved. Yeah, the diagonal, I don't think the diagonal sum might not be conserved. Like if you add them up, I don't know if you will necessarily get the same sum in the rows. No, even row and column need not be conserved if you add them up. Then if you have a 2 by 2 magic square, it's not possible, I think, because you cannot get using different numbers the same thing. Okay, so that's why this is the answer. And then we actually calculated the 7 by 7 magic squares. Sum it is 175, not 260. Okay, fine. So now on to some programming. So this is a function which does something, and that's why it's called does something. It takes in a matrix as input, does something. So for which of the matrices does the following code return true? So again, could be multiple, could be one of them. Uh, Please give the answer. So for you have to kind of figure out what this is doing and based on that give the answer. Okay, I don't understand what this message means. What do you want to do? Yeah, you can mail me about whatever. What is the issue actually? I can't understand. You can mail me about it. But if it's about you missing classes, don't worry about it. Either my class is recorded, the other videos are anyway recorded videos, so you can watch them at your leisure. Yeah, you can mail me if you have any. I don't really understand what your issue is, Sunanda, but you can mail me. Others, please put your answers in the chat. Oh, okay, there's no numbering here. Oh, okay, but you can just consider this to be A, B, C, D. Yeah, I only see one person who's answered in the chat. Others, please give your answers as well. Okay. This person says C. How to program text? The marks will not give a program. Again, I don't understand what you're trying to say. Can you just ask the question again? How to do a program test? Are you asking? I don't understand what is the issue. Hey, I don't see any other answers in the chat. Are you guys having some issue to do this program? Does everyone understand the program? You have to just figure out what this function does and tell me for which of the matrices the program says true. Okay, someone says all of them. Okay, A. Someone else says D. No, that's what you have to figure out, right? What is this program doing? Try to see the code and figure out. I don't see a clear majority yet on what any one answer or the other. Maybe A is in majority, but so please, I'll give you one more minute. Please write your answers in the chat. Okay, someone says all. B. Okay, I'm going to give one more minute and then we'll go to the answer. Yeah, I'll explain. But first try it once and then we'll go to the answer. Okay. Okay, multiple of you are saying one, all. I'll just give one more minute and we'll go to the answer. Okay. Okay, maybe we can go to the answer now. Or wait. I said one more minute, right? Okay. Okay, I'm going to go to the answer now. So the answer is all of the above. So I think some of you had got this. The reason is that this is a program which you might have guessed is one that checks for magic squares, right? Because if you see here, the the function takes a matrix as input and R is the length of the matrix, which is nothing but the number of rows. So as long as we have a number of rows and columns to be equal, then only we'll have first it checks if it's a square matrix or not. So if R is not equal to length of matrix of 0, that's basically each column, right? So if the length of the column and the length of the row are different, then it definitely cannot be a magic square because it's not even a square matrix. So the expected you take as the sum of the first row. So matrix of 0 basically gives you the sum of the first row. Then after that, for every row in the matrix, you check if the sum of that row is the same as the sum of that the other row. So if any of them are different, then return false. Similarly, now you're checking if the matrix column sum is the same as the um, expected sum. Again, if that is also false, then again you don't again you don't have the thing. And then again, the last one is for the diagonals. So that's how you do it. Oh, sorry. So this is for, sorry, I said wrong. This is for the sum of the rows. This is for one of the diagonals and this is for the other diagonal. So that's how you check it. Okay, so this is why this is a matrix, this is a magic square program. So just check that all of these are magic squares. So we know that it's n into n square plus 1 divided by 2. So magic square of order 3 means that 3 into 9 squared plus 1 is, 3 squared plus 1 is 10. So 3 into 10, 30. 30 by 2 is 15. So all of these should give some 15 along the rows, columns, and diagonals. And I'll leave it to you in your own time to check whether that's true. And you can also write this program and check if it is in fact a magic square program. Okay, next question. Suppose you want to simulate the birthday paradox by generating random birthdays for a group of people. Which library function would you most likely use to create random integers representing birthdays? Again, we have kind of used this before in some of the previous weeks. Okay, I can see that a lot of people saying A's, and then so one person is saying B or D. So I think we can go to the answer. The answer is actually A, as the majority of you said. Random.randint actually gives you a random integer, and we had used not exactly this function, but some other functions from the random library in previous week classes as well. So you can go and check those also. Which of the following are the functions in the datetime module of Python? So I think you might have used the datetime module this week in various programs, so you can go and check. Okay, I can see a lot of people saying A again, A, B, A or C, A and B, A, A and C. I'll give one more minute in case people are still solving. Ma'am, is Python application there an exam for checking and writing programs? I mean, I would imagine so. I'm not very sure. Again, this is a question that would be better asked to the discussion forum so that you can clarify with the people who are in charge of conducting the exam. I am not really in that position. Okay, we can go to the answer maybe. The answer is actually A and C. So again, in such cases, the functions in a module, you usually get used to them the more and more you use that module. But in any case, every library in Python has something called a documentation page. So if you ever want to learn something about a package or a library, what you can do is I'm so sorry. Yeah. What you can do is you can go to that particular whatever the library is, and you can see its documentation. So if I just search datetime module of Python documentation, not interested. So here you can see, for example, the datetime module. So here you can see it will give you basically all of the different functions and objects that are part of this library with their explanation. So in real-time programming, you're not expected to remember all the functions and things. So maybe for certain exams you have to do that. But when you're doing programming in a practical sense, when you're doing it for your projects or when you're doing programming in a serious sense, you will usually not just memorize everything. You will try to refer to documentation or something like that so that you can have it handy what you need to use and when. So, for example, I was talking about NumPy before. So, again, if I search NumPy documentation, then you can find, this website where all the NumPy, so we can go to the latest version of NumPy, which is 2.3, and you can actually go to the website. I don't know why it's slow. Okay, my internet is a little slow for whatever reason. Okay, or let's take something else. There's something called SciPy, which is used for scientific operations. So yeah, okay, the NumPy rep came. So you can see that NumPy, it gives you all the getting started. You have a beginner's guide for some of the main concepts, then user guide, and you can go to any of them and you will find example cases of how to run a function, what are the inputs, what are the expected outputs with examples, for example, for there. So if you want to understand a library or if you want to refer to something, so this is SciPy, for example. If you go to their documentation, I don't know why the NumPy website is so slow. Okay, it came. So you can see, right? Array creation, input, output, data types, all these different things are there. You can go to any of them and they will tell you how to do these things. And if you have some functions that you want to use, you can see, for example, numpy.gen from text is used to read text files. Similarly, in SciPy also, you can find the user guide, and then from user guide, you will find all these scientific things that people use, like for different fittings and interpolations and so on. So, point is that whenever you see a new module and you want to learn more about it in Python, which you will see again and again, depending on what your purpose of programming is, you might be using different user defined libraries and things. So in that case, just go to Google, just search for the documentation. You will find a website where all of this is maintained, where all the functions that are part of that library, along with example use cases, will be presented, and this will be a handy resource for you. Again, for the purpose of exam, you might have to memorize some things, but again, these things also are it comes with practice also. So, for example, when you first started learning multiplication, you had to memorize what's 5 into 3, but now you don't have to even think about it, right? It becomes like that. So for that, you really need to practice and practice and practice, and that's what these sessions are doing, hopefully. Okay, so this is a long question. So let's try to first understand what the question is asking. The masked gun game is a simple guessing game where the player attempts to unlock a masked gun by correctly guessing a secret 4-digit code. So it's kind of like your guess the movie game which you were seeing in the class. Arrange the steps in the correct sequence to create a Python code for the game. So they have given you 6 steps, right? So 6 steps have been given: implement game loop, display masked game gun, generate secret code, etc. The answer will be a secret sequence of numbers. So suppose the answer is six. Six should be the first step, then one, then two, then three, then five, then four. Then the answer will be 6, 1, 2, 3, 5, 4. Like that, you have to give the answer to be the sequence of numbers. The first step of the number corresponding to first step, second step, third step, until the last step. Did everyone understand the question? Okay, I hope everyone understood the question. Please like read the options carefully, read the steps carefully, and then try to arrange them. Okay. Uh, what do you mean, A? So here the answer will be a sequence of numbers. There is no option A, B, C, D. The answer will be like 6, 5, 4, 3, 2, 1, for example, or something like that. First, you have to say what is the first step, then the number of the second step, and like that, you have to give the answer. Okay, please repeat one more time. Okay, okay, I just saw that message. Basically, here a number of steps are given for giving a program, which is a guessing game, like your guess the movie game in the lectures, where some a player has to guess a secret four-digit code, but the steps are out of order. So you have to order the steps correctly. The first step it's not in order, so you have to do put the sequence correctly so that it gives the correct Python program. So for example, for free, I'm telling you, ending the game is going to be the last step, right? It's not going to be the first step. So five should come at the end, like that. Okay, I can see some answers in the chat. I hope the question is clear to you now. Okay, 21465, 312 645. I'll give a one more minute in case people are still reading and working it out. Okay, I can see many people saying 213645, 321645. Okay, maybe we can go to the answer. Okay. The answer is actually 321645. So first you are going to generate the secret code because that is what you need in the first place. Then you can display the masked gun. So these two can actually, I think 3 and 2 and 2 and 3 would be equally valid in the each order. But the rest of the steps has to be done in the correct order. So I think 2, 3 or 3, 2 should be fine according to me. After that, you implement a loop, a game loop, so that you're setting up a loop to check for each time if the secret code has actually been guessed. After that, what you're doing is providing feedback based on the correctness of the guess. So you're going to tell them if at least one letter is correct, or some other or sorry, not letter, number is correct, or how many attempts are left, and those kinds of things. And then validate and compare. So every time they give a guess, you have to compare it with the, sorry, so you give the feedback after comparing. I'm so sorry. So first you implement the loop, you compare, and then based on the comparison you give some feedback. Then of course at the end you end the game. So this is how the sequence should go. Okay, fine. So I think most of you who have answered have got it correct. Again, this 3 and 2 and 2 and 3 could be in a different order, but 1645 has to be in that order. Okay, next question. To implement a magic square, we use the concept of matrices, right? Because magic square is nothing but a square matrix. Select all the statements that are true in this context. Okay, I can see people saying A, B, A, C. Okay, lots of people saying A and B and A and C. Most of you are saying, okay, A, B, and C. So maybe we can go to the answer. The answer is actually A and B. So you can put matrices in two ways in Python. One is through nested lists, where you have a list of lists, for example. That's what's called a nested list. That gives you a matrix, like we saw in that function. The other is NumPy, which we just saw the documentation of. So NumPy is one of the standard libraries associated with implementing matrices, as they have mentioned. So implementation of matrices not only through lists, you can also use NumPy objects to represent matrices. So that's why C is incorrect. Is that fine with everyone? Okay, let's go to the next question maybe. Yeah, okay, fine. Thanks. Okay, great. Now this is a coding question, so maybe I'll give you some time. What is the output of this piece of code? Okay, so this is basically the code. On the right side is what the code is. So you can see that there's a list 90, 47, something, something. There's a sub list, and then something is happening in a loop. And then the finally this S is being updated somehow and printed. So again, this is basically about what slicing looks like. I think I have discussed this in one of the previous weeks, but basically when you give something like L of 1 colon 3, that gives you all the elements from 1, the first element, sorry, from the element number 1, which will actually be the second element because indices start from 0, right? So 0, 1, and then it will give you the second element also because 3 is not included. It's like a range. And then the other thing is that concatenation of list is similar to string. So if you these concepts are relevant to when you solve this problem. Sorry, is there a question? Someone has a hand raised. Is there a question? Do you want me to unmute? Okay. Okay, I can't see that anymore. Fine. So I'll give you some time. Read the code carefully and tell me what will be the output of this code. Okay, someone says A, someone says C. I don't see any other answers. Okay, those of you solving continue to solve. One more person says C. Okay, can see more answers in the chat. Seems to be between A and C at the moment, which one person saying D. Okay, more C's. Okay, maybe we can go to the answer. Seems to be majority C. The answer is actually C. So as you can see, the what this loop is actually doing is it's ordering the list in a ascending order, right? Keeping the smallest element, then the second smallest element, so on. So this is actually called sorting. It's a very interesting process. It's not so trivial. This is one of the ways in which you can sort, but there are many algorithms to sort a list. This is one of the ways in which you do it. So here essentially what we do is we start off with taking the first element, then what whenever we find an element that's smaller than that, we place that before the already existing element. And then what we are trying to do is every time find out what is the smallest element in the list and place it at the beginning of the list. And like this we keep placing things at the beginning of the list, so that the smallest element eventually ends up in the first position, then the second smallest element, and so on. And that's how you get the ascending order list. So you can try writing this program down in your Python interpreter and run it, and you can see how S changes in the loop. So you can, for example, you can print S after every iteration. You can see how first it is the smallest element which comes to the beginning, then the second smallest, and so on. Okay, so this is how it works. Great. Next question: what does random dot choice function do? Okay, I think most of you have answered. The answer is B, which most of you have given. It selects a random element from a sequence. Correct. Why didn't we simply write sort in the previous question? Because it's important to know that even sort is doing something like that when you want to sort, right? So it's it's not really yeah, you should know how your algorithms work. If tomorrow you can't use a user defines function, you should also try to write it on your own. Okay, fine. So previous question, flag line. Okay, so here what is happening is, okay, let's try to break this down one by one. Okay, so first of all, we are going through every element in the list, right? And we are comparing with S of j. So first S of j is 90, then we'll compare with 47. Then what will happen is all of the elements before 47, which is none of them because we're starting with 47, are kept in before j. Then in new j, only the particular element is kept. And then in after j, all the elements after are kept. So then you order it in this way. You order it as before j, new j, after j. Okay, like that. And then what you do is like that you continue. So here before j is just going to be nothing because there's only one element in the list. But now we have added 47 to the list, and we've added it in such a way that we are adding it before 90. So now the s index is going to be 47 comma 90, and so on and so on. Okay, so here when does flag so if L of I is equal less than L of S of j, then flag is equal to false. And flag is equal to false means that still now it's not ordered. If it fully becomes ordered, then the flag is true. So whenever you write if flag, that just checks if flag is true or false. And if it is true, it will just append. So that's why it says us dot append L of I. Because at this point, if it's fully become ordered, then it will just append whatever is the last element that is present there. That's why. If it's already ordered, then we don't need to do all this. So that's why this true condition is there. Okay. Fourth week birthday paradox. Could you please explain how we can write a Python program to simulate the probabilities of different group sizes and then plot how the increase chance of having at least one shared birthday changes as the group size increases. So is this not what was already discussed in the class? So we can do this, but then Yeah, if you have questions like this, please mail me in advance, then I can prepare the program and show you. Right now, on the top of my head, I cannot do this immediately, but you have to, probably it's there in your lecture, so maybe you can go and check. Okay, fine. Let's go to the next question. Identify the magic squares from the following. Okay, one of you says none, other says A. Any other answers in the chat? None of them. Okay. Okay, I don't think it's none of them. At least one answer is correct. None is not an option. So please check again. Why does magic square have to be of odd number? I think you can have magic square of any order. The program you wrote in class might have been for odd number magic squares, but you can have even number magic squares also, if I'm not mistaken. Okay, maybe you can go to the answer. The answer is actually A and A, C, and D. So I think some of you have got it. Most of you have said A and C. So again, I don't know if I would call this a magic square because it has some irrational numbers, but in the sense that its sum and diagonals add up to the sum of the rows, columns, and diagonals add up to the same number, it is very much a magic square because it's just pi which is multiplied by all of the factors, which does not change the sum at all, just adds a pi to the sum. So here you can see that, for example, I can just do one of these. So 1 plus 14, 15 plus 4, 15 plus 15 is 30, 30 plus 4 is 34. And similarly, if we go to any of the other rows at random, let's choose the last column. 15 plus 10 is 25 and 25 plus 9 is 34. So if you calculate like this for all of them, you will find that all of them are consistent with 34, and that's why it's a magic square. Similarly here, 10 plus 8, 18 plus 13 is 31, 31 plus 3 is 34. So again, because there's a magic square of order 4, then this one. In matrix D, each element is obtained by, if the magic constant of C is 34, what's, I mean, obviously it's 34 pi, right? It's just pi into the numbers, so it's just going to be 34 pi. That's why strictly magic square should have integers, I think. So that's why I don't know if it's a magic square in that sense, but in terms of the sums being equal, it's definitely a magic square. 34 pi. Pi plus pi is 2 pi. Similarly, pi plus 11 pi plus 16 pi plus 6 pi will be 34 pi. E is the Euler's constant, 2.71-ish, whatever it is. 20 minus E just means E is Euler's constant here. So again, that's just a number. Pi is just a number, right? So when you add if you have a number common to all of them, you can just take it common. That's the point. That's basic, like, I think that's basic algebra. So You guys should know that. Okay, next question. What task does mystery 1 perform? For B, you get the answer. Okay. For B, you get the answer as minus 4e, but it might not be so in all the rows and columns. That's why it's not a magic square. We can check that. I mean, 20 plus 10, 30 plus 8, 38. And this is what? 38 plus 30, 68. 68 minus 4e. And then here it will, I can already tell you that this is not going to add up to 68 because there's 26, 16, and 6 that is less than all of them. So it's not going to add up to 16. So that's the point. Okay, what task does mystery 1 perform? So here the code, there's some functions here, and the first function is mystery 1, which takes in a number as input and returns a list. And what is that list? Okay, yeah, thanks. I didn't check all the rows, but yeah, cool. I didn't check all the rows right now. What is the function mystery 1 of number return? That is the question. That is the question, what it returns. Figure it out. Okay, I can see D, C. Only few people have answered. Any other answers in the chat? D, okay. I can see that people are between C and D. No, it's a single option is only correct here. So not multiple options. Okay, I can see all of the options now, A, B, C, and D. I'll give you one more minute in case people are still confused. So read the function carefully, then you'll get the answer. Mm-hmm. Is an excluded or not, you figure out and give the answer. Yeah, well, we'll get to the rest of the code later, but okay, maybe we can go to the answer since people are now solving the next question, I think. But basically, yeah, this those of you said D were correct. Essentially, this takes a number as input. Then it checks which and all numbers are are perfectly dividing that number. That means it's leaving remainder 0. Remember when we put percentage sign, that is a modulus function which gives you the remainder. And here it's excluding n because you remember that range, whenever you give range of something, it doesn't consider this number. It does not consider this number. So the n is not considered whenever we give this common thing. So it gives you a list of what are the devices, not including the number itself. So that's why whenever we get a range of something, the second number is not included. So range of 1 comma 5 will just be 1, 2, 3, 4. It will not include 5. Okay. So those of you who got confused, please check it again. It's a very simple code. So for what n1 comma n2 will the variable flag inside mystery 2 be true? No, I'll explain the program after you figure this out. I'll explain the program. First, you answer the question, then we can explain the program. So now you know what mystery one does. Figure out what mystery two does, and from that you can find out what this program is doing. So I can see some people are giving D as the answer. Okay. Okay, I can see that everyone's giving D as an answer. Maybe we can go to the answer. The answer is actually 2 and 3. Sorry. B and C, right? So here what's happening is we are giving two. First of all, when we give 0, this is not going to give anything in the list, right? The list is just going to be empty because range of 1 to 0 is not going to give anything. So 0 comma 0 is not a correct answer, which most of you had given as the correct answer. So here what we are trying to do is first we found out that we are finding the factors of a number. So here what we are doing is for I in mystery of n1, j in mystery of n2, if I is equal to j, then set the flag to true, right? So, is it 2 and 3 and 3 and 4? Huh, 1 second. 1 second, I think there is a problem here. Because this should be the common factors. These don't have common factors. I think this should be 2 and 4. Sorry. I think, yeah, this should be 2 and we can just run this and see. Like, okay, for those of you who ask me how to do this, let's just make this 2 and 4. Okay. Sorry, there's some error in this question. I just copied the questions and the answers yesterday. I didn't check. But basically, what this is doing is here again, you're finding the factors of the number up till that number, right? Without including the number itself. And here, what we're checking is if any of those two numbers are equal, then only the flag is set to true and we get the common fact. That's how we get the common factors. So it's 2 and 4 also we won't get, right? Okay, one sec. Give me 1 second. Let me just check something. It should be A and B. So A and B I'm not giving because okay. 1 sec. I understood. Sorry. 2 and 3 is also correct. Because why is 2 and 3 correct? Because every number is divisible by 1, right? So definitely 1 is going to be in that list, right? So definitely every number is divisible by 1. So 1 is going to be in these list also, this list also. So every number will have a flag true. Except in the case of 0, it's not there because from range of 1 to 0 you cannot have. Similarly, range of 1 comma 1 you cannot have. So that's why 1 is not there. 0 also it can check, but anything bigger than 0 will have a flag set to true. Does this make sense? I just realized the logic. Sorry. I got confused for a second, but yeah, every number is divisible by 1. So every pair of number is going to have at least one common factor, which is the number 1. Is this fine, everybody? Okay. Does anyone have any doubts? This is because 2 and 3 are both will have 1 in their list. No, because one is there in both of their lists also. Right? 1 is equal to 1. Always you'll have 1 in the list. That's why it says if length of list is greater than 1, because 1 is going to be there by default. So for 4 it's going to be 1 comma 2, and for 3 it will just be 1. Right? So when it compares, it will see that 1 is there in both the lists, so the flag will be set to true. Is this clear? Okay. Great. So the reason is that one divides every number. So every number is going to have true. Every pair of numbers except zero, because then you can't check in the first place. One also, one comma one cannot be checked. That's why. Okay, fine. If all possible pairs of prime numbers between 0 and 10 are given to n1 comma and n2, for how many pairs would mystery 2, sorry, not 2, mystery 2 print completed? So when will this print completed? When we give the pair of prime numbers, not any other prime numbers, not any numbers other than pair of numbers. Okay, someone says B, someone else says D, D, A. Okay, B. So I can see that there's no clear majority yet. So please give your answers. Please, more people answer. There are always like more than 100 people in the meeting, but only like 20 odd people interact. So make sure you interact with the class. Okay, I can see a lot of people saying B or C or A. Read the question carefully, and I just explained what the program does. So you should be able to do this. Okay, maybe we can go to the answer. I don't think any of you have given the actual correct answer, which is D. So let me just explain this again. Maybe I didn't explain this properly. What this program does is it finds the number of whatever factors without n. Then this program compares them and sets the flag to true whenever there is a common factor between them, if I and j are equal. Now only, and then it adds them to a list, right? Now only if the length of the list is more than one, it prints completed. So we just saw in the previous example where I got slightly confused, again sorry, which is that every pair of numbers, prime, non-prime, whatever it is, as long as it's greater than 1, is going to give at least one element in the list, which is 1. Right? 1 is common to every number. 1 is a factor of every number. So the flag will definitely be set to true. But to print completed, it's not only enough for the flag to be set to true. You also need the length of the list to be greater than 1. That's never going to be true for any prime number, right? Because prime numbers will always only have 1 in common. That's the definition of a prime number. It's only divisible by 1 and itself. So it will only have 1 in common. So the length of the list is going to be just 1, because there's only one element, which is also 1. So it is never going to print completed for any pair of prime numbers. Is this clear to everybody? Again, use logic and common sense when you try to do these things, because sometimes we think we know what the program is doing, but here there are two things. There's flag and there's completed, and they're not both the same. So try to read program very carefully and understand, okay? I hope this is clear to everyone. Okay, I think this is the last question. If based on the same program, if the number of pairs of primes which result in mystery 2 to print completed are less than 1, then can we edit the code so that completed is always printed for any prime pair of primes? So we just saw that number of pair of primes, it never prints completed. So can we edit the code to print it? Yes or no? Okay. Yes, C. Any other answers? C. C. Okay. I explained the code, right? Okay, I'll explain the code when I give the solution. I've already explained the code for the past two questions. It's the same code. Okay, so I think most of you have answered. Majority of you have said C. Let's go so that we can do the programs also. The answer is C. Very good. So here I'm just explaining for the third time now. So please listen very carefully. There are two functions here. The first function just computes what is the factors of the number. Okay, and it doesn't include the number itself. So if I put 4 into this function, it will give me 1 and 2. Okay, if I put 6, it will give 1, 2, and 3. If I just put 2 into this function, it will give me 1. If I put 3 into this function, it will give me 1. 5 into this function, it will give me 1, right? Because all prime numbers are only divisible by 1 and themselves, and we are not including the number itself when we do this calculation. Now, when we define mystery of 2, what we're doing is we are finding each of these, we are calculating each of these lists and comparing the elements of the list. And if any of the elements are equal to each other, we set a flag to true, right? And what's going to happen, what we discovered is for any pair of numbers, be them prime, non-prime, whatever it is, it's always going to be true as long as the number is greater than 1, because every pair of numbers has one factor in common, which is 1. 1 divides all the numbers, right? But in order to print completed, it's not enough for flag to be set to true. The length of the list has to be greater than 1. In the current iteration of the program, the way it's done is if the length of the list is greater than 1, that means that there are elements in the list other than the number 1 itself, then only it will print completed. If we want to print completed for primes also, there is no use in changing flag or flag to false or flag to something else, because flag does not at all involve in printing completed, right? To print completed, it's only this if condition which is involved, and that's why the correct answer is C. Okay, so that's why we have to change the if condition if we want to print completed. Is this clear to everybody? Okay, good. Yeah, if you have doubts in these questions, I would highly recommend just take up a Python interpreter and write this program, print statements, and it will be very clear. Okay, good, good, good. Now, let's go to the programming assignment. Someone had asked to give more time for you to figure out the logic. As always, I had prepared 5 programs. I don't think we'll have time to do all of them. But as always, I share the slides and the programs with you. So please take it as, whatever we cannot discuss in class because of lack of time, just try to do it on your own without doing the solution anyway. And then if you are stuck in any part, you can go and refer to the solution. And if you don't understand any part of the solution, feel free to contact me and I can explain the solution to you as well. Okay, so the reason that I don't just sit and explain all 5 solutions with you to you, which I can do in 10 minutes, is because I want to give you an opportunity to figure out the logic for yourself. So please try to, I'll give you some proper time this time. Let's try to do at least 2 or 3 programs, and the remaining 2 or 3 programs I'll give you as your in the Google Drive, which you can access. Okay. So this is the first question. Create a Python program which checks whether a given square matrix is diagonal. Diagonal matrix is a square matrix where all the entries outside the main diagonal are 0. So everything other than the diagonal entries will be 0. The program should prompt the user to input the dimensions of the matrix and then input the matrix elements. The program should determine whether the matrix is diagonal and print 1 if it is, otherwise print 0. Okay. How we can contact you after the class? I give my email ID every class, right? I'll flash it at the end of this session also. You can mail me. And I found recently that, as I said in the beginning of the class, some of the mails were going to spam. So I'm sorry if I haven't replied to your mail. It's because I simply didn't see it. But yeah, if you've sent me a mail and didn't get a reply, send me another mail, or I'll start checking my spam filter more regularly from now on. Okay, I'll give you maybe until I'll give you, I think, so try to figure out the logic and try to write the program. If you make errors in the coding, it's okay. But try to at least get the logic correct, okay? So I'll give you till like 7:35 to do this. I'm not going to create a WhatsApp group. I think mail is enough and sufficient, and you can mail me on this. And every week, anyway, we are meeting for 2 hours. So it's more than enough to clarify your doubts. If you people want to coordinate and make a WhatsApp group, up to you. But I would not recommend it. I don't think it's very useful. So are you guys solving the program? Can you raise your hand if you're solving? Okay. Okay, good, good. Others also please try it out. As I said, I will discuss the solution. I'll share the programs with you, but it will be very good if you can try it yourself as well, because that's how you get practice in programming. I'll give you maybe 5 or 10 more minutes. Um, in the meantime, if people have solutions, you can share your logic or the solutions in the chat, and others can also discuss. Right. Okay, I'll give you till 7:30 and then maybe you can slowly start. Okay, someone is done. Very good. We can slowly start discussing the solution. Those of you who are trying, please continue trying, but just for want of time. And because I want to do at least two or three programs in this class, let's try to discuss the solution. Okay, so I'll slowly show the solution, but others you can, continue working if you want to do that. Okay. Okay, great. Someone has sent the solution that they have. So they have taken the matrix input, then compared the whatever it is. Sorry, compared the they've checked for the diagonal elements. Very good. So sorry, this is the wrong. Okay. Sorry. Yeah. Right. So you just check it if it's a diagonal matrix and if it is giving the correct output, then it's correct. And if it's, just check it with a few cases and it should be correct. Looks correct to me. I think what you're doing is just making sure that the non-diagonal elements are zero. And yeah, pi is not equal to j. And yeah. So actually, you can use your what was initially confusing with me was that you put count as one plus one, but finally, if count is greater than one, you're actually printing zero, which is a correct thing. So I think the program works. Again, you can just try it with a few different use cases just in case. Okay. Anyway, so this is a program I have. So let me just increase the font size. Okay. So we are accepting the matrix A, right? I'm assuming it's a square matrix, but you can, again, every programming is somewhere where you can use all your creativity. Here I've written the program in a lazy way where I've just assumed a square matrix, but of course you can also do an additional step of even trying to accept column matrices. But then if it's a column matrix, by default your answer will be zero because it's not a column matrix. Sorry, what am I saying? Non-square matrix. I'm saying if you consider a non-square matrix where the rows and columns are not equal, then by default your answer will be zero because a non-square matrix can never be called a diagonal. If it's a yeah. If I not equal to zero, j then not a diagonal. Yes, yes, exactly. You're not forcing diagonal elements to be non-zero, but that is right. So let's see what the question says. So question says that all the entries outside the main diagonal are zero, but it doesn't say that the diagonal entries should be non-zero. So I think a completely zero matrix can still be called a diagonal matrix by their terms. So I think your output stands. But let's see how I did it. Because I also did it okay, I also checked for the outside the main diagonal, but I think it's fine. If you want, you can add an extra condition for that. Yeah, I also added the main diagonal thing. So here you can see that I'm accepting the matrix. Then here, if it's not a square matrix, then zero. But here I'm anyway accepting only a square matrix, so it's fine. Then for each of the columns, if R is not equal to C and A of R is not equal to 1. Oh, sorry, sorry, sorry. Yeah, I have also. Sorry, I have not checked for the diagonal non-zero. I read my comment wrong. Yeah, I have not checked for diagonal non-zero. I have done the same thing as you. If the row and column non-diagonal elements, any of them are non-zero, then the result is zero. Otherwise, the result is one. That's all. Yeah. Okay. So you don't need to check for that. I think it's fine. Okay. So here, let's enter the number of rows to be 4. And let's enter it as a square matrix only. So I'm here now. I'm not doing a diagonal matrix, right? I'm giving just a whatever. So diagonal, what? Why is it giving one? Okay, there is some issue. Wait, let me just. Okay, there's some issue. Wait, it should give zero for these cases. Huh. Okay, 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 okay. This should, sorry, sorry, sorry. So this is why indentation is important. Thank you. I had run this program and checked, and it had run properly. I guess I gave a, I removed the space by mistake. Yeah, that's what I was thinking, that the program that works. So this is why indentation and spacing is important, guys. This is what I was telling in the beginning of the class, right? So you can see how if you don't do spacing properly, this can happen. I don't know how I removed the space, but thanks to whoever said that in the thing. So again, if I now give 1, 2, 3, 4, that should give. Okay. What am I doing? Result should be 1. Okay. Let's see if this works. Ah, okay, there's some issue. There is some issue in the code. So maybe I should do it how your friend did it, right? Where you put. Ah, okay, fine. Okay, so here what I did is I just did a very crude result modulo 2. That means if it's anything, if it's going to be modulo 2 should not work actually. I should do it as this way. If result is not equal to 0, ah, sorry, I don't know what's happening. One sec. Uh, okay, result not equal to 0, then result is equal to 1. If I do this, should work. Okay, I don't know why it's a Python here. Should be the thing. Yeah. Okay, 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 okay. Okay, let me think. Why is. Oh, sorry. Okay, now it works. Okay, great. So, sorry for that. I just had not written the program properly. So basically, you assume diagonal matrix like your friend did in the chat actually, and then whenever you get a non-diagonal element to be not zero, you just add something, and then if you finally get a result which is different than not zero, sorry, or greater than one, I guess. Okay, fine, then you can set it to this. Okay, so this is why you can do it. Okay, so this is how to do the program. I think now it works. Okay, I'm sorry about that, but it works now. Okay, so basically you assume a diagonal matrix and then you do the thing. Not equal to one. Yeah, this is the program. Let's see again if it works. Yeah, okay. Sorry guys, last week I was at a conference, so I kind of didn't have much time to make the slides and write the programs. So I might have made some mistakes. But okay, this is the fun of programming, that it doesn't work and then you have to figure out why it's not working. So this is one of the ways that you have to do it, that you have to just figure out where you went wrong. Okay, anyway, so this is now correct, and thank you to those of you who helped me. The other program, the next program. So let's go to the next program, basically. Okay, let's try to do this program also. I'll share the rest of the programs with you in the Google Drive after checking if they're working. Don't worry, there won't be any other errors in the programs. Okay. So create a Python program that adds the transpose of a given matrix by scalar. So the prompt, once you get it, the matrix, you have to transpose it, which means you're replacing the rows by the columns and vice versa. And then you're going to add a scalar, which is just a number to every element. Suppose I give you 1, 2, 3, 4. Then first you'll transpose it to 1, 3, 2, 4. Then you'll add a scalar to all of them. And if the scalar is 5, then it will be 1 plus 5, 3 plus 5, 2 plus 5, 4 plus 5. This is the program. Okay. So I'll give you like few minutes to work this out, and then we can discuss the solution for the this question. I hope you guys are solving the program. So Yeah, let me know. The issue that I had in the previous program, which I'm now realizing, is when I wrote the program, I only checked it for diagonal matrices. And of course, because my error was such that I was getting one no matter what, for diagonal matrices, it gave the expected answer. So I thought the program is correct. And today, when I give a non-diagonal matrix, I saw it's wrong. So this is why it's important that when you write a program, you should actually check it with multiple inputs. Okay, so this is a mistake I made just now that you saw live in front of you. Is that I wrote a program and I didn't check it for every case. I just checked it for some particular case and I thought that the program is correct, right? So this is the mistake that please don't do for that. Yeah, okay, okay. I'm waiting for a couple of minutes. Take your time. As I said, let's discuss only the some programs. Rest of the programs you can take it and do it in your own time. I will give you all the solutions. I'll wait for 5, 10 more minutes. 5, 10 more minutes. I can wait. Okay, someone says done. Good. I'll wait for 2 more minutes in case other people are solving. Okay, maybe we can again start to slowly discuss the solution and then we'll see what to do. Those of you who are solving, you can continue solving, but I'll just, again, let's just start discussing the solution. Okay, this is the program two, right? Program two. Okay. So again, going to enter the rows and columns, and here we don't really need to restrict ourselves to square matrices also. In the previous program also, we could have entered non-square matrices. I just didn't do that. And you can see that for each of the rows, we are adding columns and okay, good, good, good. So first, as I said, we have to now add a scalar to the transpose of the matrix. So first, let's find the transpose of the matrix. And here I've given you three methods to find this transpose of a matrix. Again, creativity in programming, right? The first, we're just going to use the usual list functions. So for each of the, first I'm printing the matrix, and then what you're doing is just transpose means instead of I comma j, you have j comma I. So that's what is done here. So in one line, you can actually do it, right? This is just this one line actually transposes it. So let's see what's actually happening. So for I in range, length of matrix of 0 means how many ever columns there are. For every column, we are just going to have matrix of j of I instead of I of j. And that gives us the transpose. And you can think about why this works. Matrix is transpose is nothing but putting I comma j into j comma I. Now the other two methods use numpy. So here The second method is, again, as I said, NumPy is a library which deals with matrices, and also it has a built-in function that transposes the matrix. So if you just put in an array or a list in, and then just put NP, NP is, so I have, first of all, you have to import a library if you want to use it. So that's why I've imported NumPy as NP. So I just gave NP dot transpose of matrix that printed the, that will print the transpose of the matrix. The other way to do it is, instead of using list, you can use a NumPy array. Okay, so again, this is also a way of having a matrix. You can just convert the list to a NumPy array, because in NumPy arrays, you can do matrix dot t, and that itself will give you the transpose. So if you do it with an ordinary list, this will not work. This will only work if it's already a NumPy array. So that's why I had to do this conversion. So these are all different ways to find the transpose. Okay, I just wanted to show you a few different ways in which you can find the transpose. After that, we're going to add the scalar. So first of all, you have to enter whatever scalar it is. Then I'm adding. So for every element in the scale, in the row, for every row in the matrix, and here I'm using res, which is actually the result of transposing the matrix. Okay, maybe I'll just call it transpose or something. Yeah, let's just call it something else, because I think res might be confusing to people. Yeah. So for this, we just add an element to the scalar for every element in the row, and then the result matrix gives me that. So the final result is just the transpose plus the scalar. So let's do. Okay, can you explain the first method? Yeah, sure. So here what is happening is, whenever I say length matrix of zero is the first row, right? So matrix has rows and columns, right? So it will, a matrix of m comma n will have, first of all, it will have m elements, which each of them itself have n elements. So the first m gives you the number of rows, and the second index gives you the number of columns. So when I say matrix of 0, that just gives me one of the rows of the matrix. So the length of the row was basically the number of columns, right? Imagine that I have 1, 2, 3, 4 in the row. That means 1, 2, 3, 4 columns are there. So for every column in the matrix, right? And then here the length of the matrix just gives me the number of rows. So this is giving me the number of columns, and this is giving me the number of rows. What I'm saying is that instead of having the row, so instead of having the rows comma columns, I'm having the columns comma rows, because that's what it transposes, right? So I have j comma I, where j gives me the elements by counting the columns of the matrix, and I gives me the elements by counting, sorry, j gives me the elements by counting the rows of the matrix, and I gives me the elements by counting the columns of the matrix. Is this clear? So instead of I comma j, I have j comma I. The original matrix had matrix element of, wherever I had the original matrix I comma j is put in the new matrices j comma I, and that's why it's a transpose. Okay, great. So let's run the program, see how it works. Okay, let me just clear this. I don't know why there's this port forwarding suddenly. Okay, good. Let me just control C. Okay, clear this because there's too much clear. Okay, and let me maximize. Okay, so let's run the program. So number of rows, let's say 3. Number of columns, let's say 2. Okay, so there are 3 rows and 2 columns. So let's put 1 comma 2, 3 comma 4, 5 comma 6. Okay, so you can see that this is the original matrix 1 comma 2, 3 comma 4, 5 comma 6. We have found the transpose in 3 different ways, right? And you can see that all 3 gave me the correct same answer, 1 3 5 2 5 2 4 6, which is how the transpose should look. Again, these two look a little different because they are NumPy arrays, so they look kind of different because NumPy formats the array differently, but they are all the same object. I mean, the values are the same, right? So now let's add the scalar. So let's add 10 to all the elements. Okay. So I'm just going to add the scalar to be 10. So after adding the scalar, remember we are adding the scalar to the transpose of the matrix. So that's where I get 11, 13, 15, 12, 14, 16. That's the answer. This is clear to everyone? Okay, it's only 8 minutes for the end of the class, so I don't think we can do one more. But let me just show you the question, and then maybe we can discuss how we could do it. So again, here the next question is, and then the last two questions again, please look at it in your own time. I will share all the programs with you. And as I said, if you have any doubts, please contact me. I am available to clear the doubts over mail. You can contact me, or we can discuss a little bit in the next class. Maybe next class onwards, I'll bring less MCQs and we can try to end them early so that we can try to spend more time in the programming also. I think the balance, I'll try to make it in such a way. Anyway, create a Python program that checks whether a square matrix is symmetric. A matrix is symmetric if its transpose is equal to matrix itself. So this is fantastic. We just learned how to do the transpose. And here is somewhere where transpose very much applies. The program should prompt the user to input the dimensions of the matrix, then input the matrix elements. The program should then determine whether the matrix is symmetric and print 1 if it is, print 0 if it's not. So already you know that the explanation of symmetric matrix is whether the transpose and the matrix are equal. You already know how to take a transpose. So now you just need to compare it element by element, right? So please try writing it. Now I showed you how to do transpose in different ways. And you can do, yeah, okay. What is the error? Can you check it now itself? Yeah, sure, sure. Can you send it? Okay, let me just run your program so I can see what is the error you're getting. Okay, let's close this. Let's right. Okay. Okay. Okay, enter number of rows 2, number of columns 3, enter the element. Okay. So 1, uh, let's say 2, 3, 4, 5, 6. Huh. Okay. So that means that your matrix itself is not being constructed properly, right? Because it's giving you 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, which is not how it should be. So let's see. Into the element L dot append of input A dot append of L. Okay. So, okay. Let me just. Okay, let's just print I and J next to it so we get an idea of which element we're entering. I'm just trying to figure out. Okay, enter the element 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Okay, but somehow when you construct the matrix out of the element, so your input is correct. 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Input is correct, but when you're constructing the matrix from the input, you are going wrong. So let's see here now. Okay, let's print. Okay. 1, 2, 3, 4, 5, 6. So you can see that. Wait. Okay, I need to see the program. Print A. So why did you do this step? Print A itself is having the. Okay. Suppose I don't have this loop, right? What's print A doing? Okay, let's just put it as 2 cos 2 for now. Others you can leave if you have anything else. Okay, I'm just going to figure it out. Okay, okay, one sec. Element 0, 0. Yeah, okay. So I think the issue is that your A is not being correctly done. Okay, so please check this out. First of all, this should be int of input because you have to have it as a number, right? So if I now, let's see. Okay, first of all, it has to be an integer. I don't know why there's two copies. I'm not able to figure out. L dot append int of input. Okay, so let's put L is equal to, because every time your row has to be new, right? Huh. So now you got it right. Now it's 1, 2, 3, 4, 5, 6. Now if you take the transpose, it will work. So what was happening was the original matrix itself was wrong. The thing was that you were not clearing L. Every time you create a new row, you have to start from an empty list because a new row is again from the beginning. So that's why here you have to have an empty list. That's what was the issue. Got the mistake, right? Okay, great. So now I had just commented out these things, but just include this. I think then your transpose will be fine and then your scalar should be fine. Okay, fine, great. So others, again, if you have any more doubts, you can mail me or whatever it is. I'll just share my mail ID and the link in the chat. Again, next class, I'll try to finish up the MCQs a little earlier. Maybe we can do more programs. That'll be good, actually. In any case, whatever programs I plan to discuss but don't have time to, I share in the Google Drive. So make sure you read the program and try to do those programs too, because that'll be useful to you. Okay? So I think we can end for today. Sorry for that program being wrong, by the way, but you got a live lesson in how to debug a program. So it happens, right? No one can write a perfect program. You have to always check all the cases. I got lazy and didn't check the cases. That's what happened. Okay. So that's a lesson to you guys. Don't do my mistakes. Okay. Anyway, that's all for today. Have a nice next rest of the week. And if you have any questions, please feel free to mail me. I'll check my spam filter also in case any of your mails get bounced. Okay. Okay then. Bye everyone. Thank you.